Okay, so now we need to fill in just, is it 0? Is it positive? Is it negative? Now, x is pretty simple, right? If x is below 0, this is negative x and this is positive x, okay? Acceleration is also fairly simple too. There's two ways to do it. The first is to just use this, right? This is simple, right? That it's negative omega squared times x, okay? So if x is positive, then acceleration is negative, okay? If x is negative, then acceleration is positive, right? So this would be negative acceleration, because in general, if we're above the equilibrium point, we're accelerating toward it. If we're below it, we're accelerating up, right? So this is positive acceleration, negative acceleration. So those depend only on the x, okay? The velocity has to do with the slope, right? So if we look at the velocity, is the slope. Okay, so let's see, if it's sloping upward, it's positive. That's a positive slope. Negative slope. Yeah, if we look at the graph like that. And by the way, the other way to do acceleration is to look at the concavity, right? This has to do with the concavity of the function, right? Any function that is concave downward, that is, it's like this, like this, like this, right? Where the curvature is downward. These are negative accelerations. And anything like this, right? These are positive concavities. That's positive acceleration, negative acceleration. Just remember a smile, right? If it's smiling at you, it's positive. Now, the reason why this is that this is the concavity is the rate change of the slope. So really, it's a second derivative. This is for math heads there, okay? The second derivative is positive if the slope is getting less negative, getting less negative, getting less negative. Here, this is negative concavity. This is the slope is getting more negative, more negative, more negative in all of those, okay? So that's the acceleration is the second derivative of position. Okay, so let's go through and look at the position here, right? At 0.3 seconds, 0.3 is right here. Roughly, right? You can imagine this is 0.2, 0.4, 0.6, 0.81, right? At 0.3 seconds, that's our first one here. X is definitely negative. At 2.5 seconds, that's here. At 2.5, X is also negative. At 7 seconds, that's right here. X is 0. At 3.2 seconds, ooh, I'm getting good at that. X is positive, right? At 5.5 seconds, let's see, 0.2, 0.4, 5.5. X is positive. At 7.7, oh, that's tricky. 0.2, 0.4, 0.6, 0.8, 0.7 is right in the middle here. All right, 7.2, 0.4, 0.6, 0.7, 7.7. X is positive. Right, the X is pretty easy, right? It's just graph reading. Then at 6 seconds, X is 0. All right, so we figured out positive, negative, or 0 for X, right? Let's look at the velocity. Now we're looking at the slope, okay? So this guy is the slope, okay? What, is this a positive or negative slope? Well, it looks to me as time goes on, this is going down. This value of X is going down. So this is a negative slope. 2.5 seconds, I think that slope is 0, right? A tangent line there would be a 0 slope. All right, 7 seconds. This is, by the way, a maximum slope, a maximum positive slope. We don't need to indicate that, but it's definitely a positive slope there, and it's maximum, by the way. Okay, let's see, 3.2 seconds. That's another positive slope right there. Yeah. Positive slope. It's going up, right? Not as much as it is at 7, but it's still going up. All right, let's see, 5.5. That's another 0 slope, right? Tangent line there is going to be 0. All right, let's see, 7.7. That's this spot here. That looks like a negative slope to me. And then let's see, 6. That's also a negative. That's a maximum negative slope. Okay. All right. Let's see, 7.7. Okay. And then let's look at the accelerations. Okay. And we, by the way, the accelerations are just going to be the opposite of these guys. Okay. Yeah. So it's 0 acceleration. But let's just go ahead and look. Okay. So at 0.3 seconds, notice that that is concave upward, right? So that's going to be a positive acceleration. It's also positive because if x is negative, the acceleration is toward the equilibrium, which in this case would be positive. Either way, right? Okay, 2.5 seconds. Well, this would be actually a maximum positive acceleration. Why? Because the x is at a maximum negative value, and a is negative omega squared x, right? So if x is a maximum, a is a maximum. Okay, in this case, it's positive because we would be accelerating toward that. The other way to know it's positive is that this is upwardly concave. This graph smiles at us, right? Okay, let's see, 7 seconds. Well, at 7 seconds, we're not displaced at all. We're moving at a maximum speed, but we're not accelerating because the spring is not distorted, right? So this is going to be a 0. Okay, it's 3.2 seconds. This is concave downward. Notice that the slope is getting less and less and less. Concave downward. We also know because it's a positive x, this would be a negative acceleration. Okay, and then at 5.5 seconds, our x is at a maximum. We're going to be accelerating toward equilibrium. So if we're above equilibrium, accelerating toward equilibrium means we're accelerating down. So that'll be a downward one. Or we can look at this and just say, look, that's downwardly concave. The cave is accessible from below, so it's negative. Okay, 7.7 seconds. That's also downwardly concave. Okay, so that's going to be a negative acceleration. Okay, another way to do it is we can say, look, our x is positive, and we're going to be accelerating, therefore, toward equilibrium. If we're above equilibrium, toward equilibrium is below us, so we're going to accelerate down. Okay. Let's see, x at 6 seconds. Okay, at 6 seconds, we're at equilibrium. Equilibrium means we're not accelerating, right? Okay. Also, x is 0. Also, this is an inflection point, right? A place where the concavity is 0. Okay, technically speaking, an inflection point. Okay. All right. Enough of that.